In this video tutorial, we are going to use the Mind Fusion diagram library from Blazor to build the floor planning application that you see on your screen. This application allows the user to draw various kinds of links and add a window or a door to the links that represent walls. The doors and windows are nodes and links from the diagram component. When clicking on an empty diagram area, a context menu shows, which allows the user to add different objects with regard to floor planning. There is an option to add text, which is also a diagram node that is transparent and can be resized. Another option is to add a server rack node, which is one of the predefined diagram shapes. This application also allows the user to save the diagram to a JSON string and also gives them the possibility to load it back. There is a button that clears the diagram area and the user can start anew. This video is a step-by-step tutorial which will lead you from creating an empty project to the last line of code to create this application. We start with an empty Blazor standalone WebAssembly project. There are small differences in how you implement the diagram if your project is a Blazor web app or a standalone WebAssembly application. Please consult the online documentation to see how to proceed in these cases. Once the project is created, the first thing we are going to do, install the Mind Fusion diagram package for Blazor from NuGet. Once the library is installed, we can declare the necessary namespaces to use, and we can also initialize the diagram view, which is the component that renders the diagram. The namespaces that we need are Mind Fusion Diagramming and the Microsoft Maui graphics, also the Graphics Skia namespace. Then, in the code section of the Razor view, we create two variables. One is for the diagram view, and the other is for the diagram. As we mentioned, these are two separate objects. We specify the bounds of the diagram, which we get from the view, and we also set the Allow in Place Edit property, which allows the user to edit nodes and links interactively. Let's run the application and see what we've done so far. This is the diagram in the browser. We try to create a link, but nothing happens. And this is because links are meant to connect nodes, and since there are no nodes, we cannot create any links. If we want to create links simply by drawing on the diagram, we need to set the Allow Unconnected Links property to true, which is what we just did. Now, when we draw on the diagram area, links are created just as expected. The behavior of the diagram is set with the behavior property, and the enumeration that lists the behavior types has a lot of options, so you can choose the one that best suits your application needs. We set the back brush property of the diagram, and we also show the background grid to help us with item alignment. The next thing we do is to declare some brushes and pens, which we are going to use when we style our diagram. Styling the diagram is done through styles and themes, and there are a lot of properties for that. Let's check the diagram link style property, which is a class, and exposes many options to specify how to diagram links look. The same property for nodes is called Shape Node Style and allows you to fully customize the look of your nodes. We use those two properties to specify the stroke and stroke thickness of diagram links, as well as the font for diagram nodes. Regarding the font, we use Timok, which is not available in a web application by default, so we need to import the font definition files. More about that later. First, let's run the app and see how we are doing so far. With the appearance properties we have set, our links look more realistic as to what we want to achieve. Now we are going to wire some events. The online documentation shows a long list of diagram events. We start by handling the link clicked event. When a link is clicked, we want to show the context menu. First, we have to check if the button is the right mouse button, and if it is, we are going to show two menu items. A click on each menu item triggers a different method, which we are going to write. Of course, it is important that we know the position where the mouse was right-clicked. The next thing that we need is a shape for the door. This is going to be a custom shape. There is no suitable shape for a door in the set of predefined shapes, so we will use the shape designer to create a custom shape that represents a door with the space needed to open it. This shape is basically two lines and an arc. You can use the online shape designer to create the shape, and then you can export it as a file on your hard disk. The online shape designer allows shapes not only to be saved, but to be loaded. If we open the custom shape that we have for the door, you can see that it consists of three elements, two straight lines and an arc. The shape is saved in an XML file, and we need to include it in our application so we can load it in a diagram. For that to happen, we need to mark the shape file as an embedded resource. And then we are going to write a method which we call loadShapeLibrary, and there we will read the custom shape. We need a class variable for the shape library because we are going to access it in other methods as well. In the method, we simply read the file as a stream and load it into the library with the loadFromXML method. If you look in the XML file, you will see that the ID of the shape is doorShape, and this is how we are going to access it. In the link clicked event handler, we have two methods, addWindow and addDoor. Both of them use helper functions to get the y or the x of a point. These are mathematical functions, which calculate the coordinate of a point on a straight line. Depending which function you call, you either get the y or the x coordinate of the point on a line that is defined by 2 points, which are provided as parameters to the function. We need to know whether the link is horizontal or vertical, and we decide that based on the difference of the x or y coordinates of its start and end points. We use the createDiagramLink method of the factory class to add the window link. The factory class is exposed through a property and is used to create all types of diagram objects. Once we insert the new link that represents the window, we need to check if it ends before the end of the original link. If yes, we need to draw the remainder of the initial link. Last but not least, we use the tag property of the link to store information. We keep there a bool flag that keeps track whether the link represents a wall, e.g., whether a click on it should render the context menu. The tag property is of type object and is available for all diagram elements. You can use it to store any data relevant to your application logic. The add door method. It's similar to the add window method. It just creates a shape using our custom door shape that we loaded in the shape library. Again, we get the start and end points of the original link, and we use our getX or getY methods to calculate the coordinates of the other point of the new element. Afterwards, we create a new diagram shape with the form of a door. We check if the shape spans to the end of the original link, and if not, we draw the link remainder. We set the enabled handles property of the newly created element to adjustment handles all. This means that the user can resize and rotate the node. It is also possible to flip the node with mouse drag because we set the allow flip property of the new node to true. Let's test our application now. Here is the diagram area. We draw our link, and if we right-click on it, we can see the context menu. We can insert either a door or a window. Now let's look at the properties of the shape node class. You can see it has an image property that is of type iImage. So, in order to create the other type of nodes that render pictures, we need to load and convert the images to iImage. First, we copy the images in a folder in our project directory. Then we mark them both as embedded resources. We add a new method that reads the contents of each image file as a stream and creates an iImage object from it. We use the Skia image classes for that. Remember, we imported the namespace. Now we have to handle the clicked event of the diagram. We add a new event handler, which shows another context menu with more options. Depending on the chosen option, we create some nodes with images or diagram links. Let's add the method that creates a shape node, which displays the computer image. This is a transparent node, and it gets the iImage for the computer.png file. The next method is for the LAN socket, and is the same as the computer shape node, only there is an outline pen because we want to style it this way. The image, of course, is taken from the LAN socket image file. The text node and the server node are similar, only that the server node uses one of the predefined shapes, which is called procedure. It also displays a text. If you look in the online documentation, you will see a page that is called Table of Predefined Shapes. There, all predefined shapes are listed with their name, so you can access them from the Shapes class. As you see now, we missed two properties. One is for the current pen, and one is a Boolean value called isWall. Let's add those two variables. The isWall property is set to true by default because when the application starts, the users can draw diagram links, which represent walls. When the user selects another option from the context menu, we should change this bool flag to false. Now let's run the application and see the results so far. We want to draw lines. When we right-click on a wall, the context menu that appears is different from the context menu that appears when the user clicks on an empty diagram area. As you see, we still have not added the code that draws different diagram links for walls and cables. Let's handle the link created event, and there we are going to use the current pen variable to specify the right pen for the new link. We also use the isWall variable to specify the type of diagram link that is being created. This is important for rendering the context menu. Only diagram link instances that represent a wall show the context menu. Now we edit the linked click event and check if the link has a tag property set, and if yes. If it is set to true, this means the clicked link is a wall. Otherwise, we exit the method and do not show any context menu. It is time to expand the user interface and add the buttons to save the diagram, clear the diagram area, and load the diagram from a JSON file. Let's start with the clear diagram event handler that just calls the diagram's clear all method. It removes all items from the diagram area. Now we are going to handle the Save to JSON button click. We call the Save to JSON method of the diagram, which exports the diagram to a JSON string. As you see, the diagram has plenty of methods for export and import. After we get the JSON representation of the diagram, we use a memory stream and call a JavaScript method that will save the diagram to a file. We use pure JavaScript to generate a stream and then create a binary object. We generate an HTML link element and initialize a click on it. The click downloads the binary object as a file using the user browser. For that to work, we have included the JS runtime classes. Let's run our application now. We create a few dummy nodes and links and save them to a JSON file. Let's clear the diagram area and load the newly created file. Here it is. So far, so good. You may have noticed that the links we draw end up being what we want, but while we are drawing them, always the black link for the wall is rendered. This is because we have handled the link created event, but we also need to handle the link creating event in order to update the links while they are being created. The link creating event is basically the same as link created. And now, our links are being drawn correctly. And with that, our tutorial is finished. We've walked you through all the steps to create a floor planning web application using Blazor. You can find the full source code in the video description. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.